Hello, guys. Welcome to Ramta Solutions. Welcome to your lesson on probability. Today, we are looking at letter arrangements where the letters are repeated. So, all the videos so far, when we were dealing with counting principle or factorial notation, or all the videos so far on probability, your grade 12 probability, when we were dealing with letter arrangements, if you noticed, those words did not have repeating letters. If you can remember, they did not have repeating letters, right? Now, what if we have repeating letters? So we want to know how many words can we make out of these repeating letters. For example, let's consider the word mom. Okay, let's consider the word mom, M-O-M. How many words can we make out of it? Manually, we're going to say mom. We can have M-O-M. We can have O-M-M. We can have M-M-O. I don't think we can have any other word, but you guys can tell me, can we have any other word? I don't think so, right? I don't think so. So these are the possible words that we can make out of the word mom. It can be M-O-M, O-M-M, or M-M-O, right? Okay, so how many words can we make? We can make 3 words. Okay, we can make 3 words. Now, let's look at beeb. Let's see. We can try B-E-B. How about B-E-B-E? Baby. And then let's then say we can also have baby, E-E, right? I think we can also have E-E, B-B, and we can also have E-B, E-B, all right? We can also have E-B, E-B, all right? E-B, E-B. We can finally have E-B, B-E, right? So what I'm seeing here, we can have 6 words that can, we can have 6 words from B-E-B, right? We can have 6 words from B-E-B, right? So now we then say, okay, so far we have seen that, you know what, with our math skills, we are content to say, you know what, the way we are, we can somehow create formulas, right? We can somehow create formulas. So now let us see, there is a formula that we can create, and there is a formula that we use. So let's go to the next page and say, generally, when a letter has, or rather, when a word has n letters, let's fix this. When a word has n letters, and this M1 is basically M sub 1, and this is M sub 2, and this is M sub 3. So let's start afresh. When a word has n letters and M1 letters are identical, M sub 2 letters are identical, M sub 3 letters are identical, and so on. Number of letters can be given by n factorial over M sub 1 factorial multiplied by M sub 2 factorial multiplied by M sub 3 factorial multiplied by, and so on. So this one here is the formula that you're going to use. This is the formula that you are going to use when you have repeating letters in a word. Okay? When you have repeating letters in a word, this is what you're going to use. So remember, n letters in a word, this is your word that's given. Now m sub 1 are the letters that are repeating. How many times are they repeating? That's basically your m. I repeat, n is the number of letters in your given word. M is the number of identical letters in that word. Okay, if you have more than only one letter that's identical, it'll be that m only. But if it's identical 2 times, it'll be 2 factorial. But if it's the only one, it'll be n factorial over whatever 2 factorial. If there are 2 more letters that are identical, for example, 2 different letters that have identical letters, you will say m1 times m2, but we will look at that. So to help you understand this formula before we go far, let's look at the opening examples we used. Mum. Mum is made up of, I'm going to change the color. Let's talk mum. Mum is made up of 3 letters, so it's 3 factorial. Only m is repeating, but how many times is it repeating? Twice, so it will be 2 factorial. So what is your answer? Your answer is simply 3. Okay? Your answer is simply 3. Okay? Your answer is simply 3. Now, when you have one letter that's repeating, on your calculator, you can choose this one here. I don't want to talk about it, but yeah, NCR. Okay, you can choose NCR. So you will say the word has 3 letters. For example, for mom, the word has 3 letters, C. So this is combination, 3 letters, but one of the letters is repeating twice. Okay, and trust me, it will give you 3. But note, guys, do not use this. Okay, do not use this. Right. Now, going to Beeb. Now, Beeb has how many letters? The word Beeb has how many letters? 4 letters. Of the letters, there are 2 that are repeating, right? One of them is E, is repeating twice. Another is B, is repeating twice. Can you see now? E is repeating twice, B is repeating twice. Now get your answer. What is your answer? Your calculator is telling you that this is 6. Now let's go to our opening example. We said B, we can basically make 6 letters. For mom, we can make 3 words, not 3 letters, 3 words. For B, we can make 6 words. Can you see that? So this is the beauty of it. Okay? This is the beauty of it. So I'm no longer going to talk about NCR. I'm just going to let it slide. Okay? So we're not going to talk NCR. But if everything goes well, I might have a video on it, because this is basically in your university. All right, moving on. Example 1 says, how many letter arrangements can we make from the word Omo? Omo, washing powder. So what are we making? Let's see. We are saying from Omo, of course, we say n factorial over m sub 1 factorial. Right? Even if you don't write this, it's okay. Omo is made of 3 letters. Letter O is repeated twice. So here is it. Get your answer. So there are 3 words or 3 letter arrangements. Right? There are 3 letter arrangements. Right? There are 3 letter arrangements that you can make from Omo. Right? From Omo. Right. Let's go to the second one. The second one says, how many letter arrangements can we make from Mississippi? Mississippi. How many? I see 5. It's 11, right? So Mississippi n prime over m sub 1 factorial times m sub 2 factorial times m sub 3 factorial. There are 11 words that are making 11 letters that are making up the word Mississippi. Now, let me confirm. This is fine. Yeah, it's 11. So, 1, the I's are repeating 3 times, right? The I's are repeating 3 times. The I's are repeating 3 times. The S's are repeating 4 times. The P's are repeating how many times? Twice. Let me confirm. Mississippi. Okay, no, I was wrong. The I's are repeating 4 times. Yes, now it makes sense. The I's are repeating 4 times. The S's are repeating 4 times as well. The P's are repeating twice. Can you guys see that? The I's are repeating 4 times. The S's are repeating 4 times. The P's are repeating twice. So yeah, because M is the other different number. So 4, 4, 8. This is 8 and 10. So it makes sense. So what is it? Mississippi. Let's see. It's 11 factorial over 4 factorial multiplied by 4 factorial multiplied by 2 factorial. So how many words can we make? 34,650 letter arrangements. Oh my. Please do not ask me to do this manually. Okay, please do not ask me to do this manually. This is where when I tell you that please give me 200,000 rands so that I can give you all the words. Okay, so this is it. This is the number of letter arrangements that you can make from the word Mississippi. Okay, perfect. Number 3, they say there are 3 maths textbooks and 5 science textbooks. How many ways can they be arranged if they are treated as identical? So you have the maths textbook that all of you are using in class. Alright, so we want to know how many ways we can arrange them. Okay, you want to know how many ways we can arrange them. So it will be 1 maths books and science books. In total, it's 3 plus 5. So we have 8 books. So n factorial over m sub 1 factorial multiplied by m sub 2 factorial. What is this? Together, they are 8 books. Now, there are 3 maths books, and then there are 5 science books. Now, let's see. 8 factorial, calculator, 3 factorial, times 5 factorial. So, the calculator returns 56 arrangements. Okay? There are 56 ways in which you can arrange these books. Okay? There are 56 ways in which you can arrange these books. Okay? There are 56 ways in which you can arrange these books. Alright. Perfect. So this is it, guys, and I hope you are enjoying it. Moving on. Now, we have the word excellent. Let's see. The word excellent is made up of how many letters? 4, 9. I think it's 9 letters. Right? The word excellent is made up of 9 letters. It's okay. So, question A says, if repeated letters are treated as different, how many letter arrangements are possible? Number A is easy. it'll be, because they are treated as different, right? Because they are treated as different. When you choose one letter, you then, for the first letter, you then have 8 for the remaining, just like that. So it's 9 factorial, all right? It's 9 factorial. So our answer is 9 factorial. What is it? It's 9 factorial, 9 factorial. That is 362,880 letter arrangements. Okay? Letter arrangements. Okay? If anyone is in doubt or does not understand how we got this, remember I had said, they say all these letters are different, repeated letters are different. So meaning you can, if they are different, maybe on the surface it's L, but you find that it's something else. Maybe let's call it L1, L2. Okay, maybe let's call it L1, L2. For the first place, you will choose one of the 9, and then that means you have 8 for the second. Then you will choose one, you have 7 for the second. You choose one, you have 6 for the, just like that. Right? Perfect. Now, number B. If repeated letters are treated as different, oh no, it shouldn't be seen as different. It should be seen as identical. Let's fix this as identical. Okay, let's fix this as identical. Okay, we're going to fix this as identical. If repeated letters are treated as identical, how many letter arrangements are possible? Okay, all right. So this is it. All right, so let's see. If repeated letters are treated as identical, how many letter arrangements are possible? This one, let's see, number B. Number B, we said n factorial over m sub 1. Let me check how many are repeating. Okay, it's E and L. Okay, it's m sub 1 factorial times m sub 2 factorial. So the word excellent has 11 letters. E is repeating 3 times. Yeah, it's only E. Is repeating 3 times. L is repeating twice. L is repeating twice. So does it mean we have 6 different letters? Let me see. 1, 2. Oh no. Oh, it's not 11, it's 9. Why did I say 11? It's 9. Sorry, it's 9. It's 9. Sorry, it's 9. Okay, so this means we have 4 different, because 3 plus 2 is 5. So we have 4 different. Let me see. 1, 2, 3, 4. Correct. Okay, so now we have 9 letters that are making up the word excellent. Right? We have 9 letters that are making up the word excellent. But 5 of them are repeating, 3 of the same kind and 2 of the different kind but similar kind. 2 but different to this 3. Okay, let's see now. Taking out our calculator, this is 9 factorial over 3 factorial multiplied by 2 factorial. So what do we have? We have 30,240 letter arrangements. Okay, letter arrangements. Okay, letter arrangements. All right, perfect. Number C, what do we have? Number C, what do we have? They say if the first and the last letters are identical, how many letter arrangements are possible? Be careful. The first and the last letters are identical. See. So we have the word excellent, right? We have the word excellent. We have the word excellent. Let's say starting with E. Start and end or starts and ends with E. Let's look at it. This is it. This is E. There are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is another E. Right? Let's see. The first and the last letters are identical. Okay? No. It's 1. It's 1. Remember, now that you cannot consider this E and this E, they are already out. Okay, so that means you have 7 to work with. Of the 7, you need to be careful. Of the 7 that you have here, okay, of the 7 that you have here, you have 7. Let me just emphasize it here. You have 7 letters to arrange. Out of the 7, only your L's are repeating. All right, so it will be 7 over 2 factorial. All right, it will be 7 over 2 factorial. So this is building up on what we were doing. Remember, this E and this E are out. We only have 7 letters to deal with. Now, having the 7 letters to deal with, the 2 of the letters are identical. Hence, I'm saying 7 factorial over 2 factorial. Let's go ahead. 7 factorial over 2 factorial. Okay, so what is this? Maybe somebody's wondering, why didn't I use the formula? It's okay, guys. You can ignore it, but for the sake of consistency, let's say this is n factorial, red color, n factorial over m sub 1 factorial, which is now 7 factorial over 2 factorial. Now our answer is 2,520 letter arrangements. Okay, letter arrangements. Okay, the reason why I didn't do your what we call your counting principle, I didn't use it, was because the L's are repeating, so it was going to take a different form. Okay, because you were, if you wanted to take the the counting principle, you're going to say 7, 6, 5, 4, 3, 2, 1, which is not really the case because the L's are identical. And remember the statements, if okay, didn't say much, but because the L's are identical, we know what we have been doing, that it will be 7 factorial over 2 factorial. Hence we say 2,520 letter arrangements. Okay, perfect. But we are not done. It is not only E that is repeating, even L. Okay, so the second one is starts and ends with L. What do we have? L, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's another L. So this is 1, this is 1. Now we're only sorting these ones out. So what is it? N factorial over M sub 1 factorial. What is it? 7 letters. Oh boy. 7 letters are remaining. But of the 7, 3 of them are identical. What are they? They are the L's. Right? They are the E's. Sorry, they are the E's. The E's are identical. So this will be 840 letter arrangements. Okay, 840 letter arrangements. Okay, does it make sense? All right. Now we are not done. Remember, the words could start with E or could start with an L. Therefore, let's just say 2,520 plus 840. What is it? It is 3, 30, 60, 20. right? 2520, my memory serves me well, 5360 indeed. So 2520, yes, it's 2520, right? Therefore we have 3,360 letter arrangements when a word starts and ends with the same letter arrangement, right? You guys get it? When a word starts and ends with the same letter, we have 3,360 letter arrangements, right? That is because letters could start with L or they can start with E. Okay? Perfect. Now, number D, they say how many letter arrangements can be made if the letter starts with an L. Okay, with an L. Okay, is that D? It's D. So D, it starts with an L. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're not going to waste our time. So if L's are repeating twice, alright? L's are repeating twice. So we're going to say, because one L is taken out, we are left with 8 letters, right? And only one letter is repeating so many times, alright? So only one letter is repeating so many times. So we have 8 letters to choose from. Out of those 8 letters, 3 of them are the same. Now what is our answer? 8 factorial over 3 factorial. Now this is 6,720 letter arrangements. Okay? Okay. This is it. When it starts with an M, that's number D. Alright, let's go to, remember what I had said. I had said to you, do not make a mistake of using factorial notation here and saying, okay, it's now 8, 7, 6, 5, 4, 3, 2, 1. There are letters that are repeating. Okay? Perfect. Number E, now how many letter arrangements can be made if the arrangement starts with a T? Oh boy. Okay, number E, it starts with a T. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if it starts with a T, what I know is that n factorial over m sub 1 factorial multiplied by m sub 2 factorial. Why? Because the L's are still repeating, the E's are still repeating. How many letters do we have if the T is out? We have to arrange with this 8 remaining. So it's 8 factorial. And then we still have our L's. How many L's? There are 2 L's and there are 3 E's. Now let's get our answer. Our answer is simply 3,360 letter arrangements. Okay? It is simply that. So with that being said, it's a wrap, guys. I hope you guys are enjoying this, but not just hoping that. I also wish that you excel in your examination. Okay? So all the best and bye-bye.